Yeah, MONAI Label so was created in a collaboration between KCL and NVIDIA. That was what I wanted to say. This is the agenda that I'm going to follow for today. Very quickly describe what is MONAI Label, why we should bother using MONAI Label, quickly how to create a MONAI Label app for segmentation, the active learning strategies, briefly what is an active learning strategy and how we can use it with MONAI Label, some radiology use cases that we presented in the Slicer hackathon. Very interesting to show. So MONAI Label is a framework, it's open source, and it allows you to create AI annotation models. What it means is that you can do training, you can do inference using single deep learning models and multi-stage deep learning models for segmentation. So depending on the complexity, you decide I want to use a single stage or multi-stage. It also includes active learning is one of the libraries that allows you to do active learning. If you want to play with that, very easy, you can pip install MONAI Label or use the Docker container for MONAI Label. And just as a reference, we created plugins for the different applications. We use 3D Slicer and OHIF. So you want to play with the radiology application. But also recently we add pathology and endoscopy for video segmentation. So this is the summary of the applications that we offer in MONAI Label. We have in MONAI Label radiology, which is the most mature one, but we also have pathology and endoscopy. Bundle is an initiative to a way of packaging AI models within MONAI. So you create an AI model and you package it in a bundle format, you can consume it in MONAI Label, right? So you can start the server and serve the AI model that you create in MONAI. So what is MONAI Label is a server client system. So we have three main components. The server, of course, where we host everything, all the apps, radiology, pathology, endoscopy, and the bundle. We also have a scribble-based algorithm for segmentation. The active learning strategy, you want to use the active learning strategies, and we have a heuristic runner for the radiology app. That's the server side. So we also provide support to the DICOM web standard. So you have an endpoint with DICOM web, you can connect MONAI Label to that endpoint. Or you want to work on your local computer, you have a data store, a class that basically manages the data set that you have in your local computer. That's the server side. But you also have the interface, the GUI or the plugin. And again, we have CVAT for endoscopy, QPath, and there is another one for pathology, 3D Slicer and OHI for radiology applications. We already mentioned a lot. 3D Slicer is very popular, but for those that are not familiar, it has a super, it's a very supportive community, and they every 6 months. This week is the Slicer week, where you can participate and learn from all the people that are using a Slicer. The great thing is that you can create modules. It's easy to customize, and that's why we decided to have a user interface that allows you to interact with the MONAI Label server. So this is one of the plugins that we have in Slice in MONAI Label. The other one is the OHIF, completely web-based, so you don't need to install anything. This has to be connected to the DICOM web, so you cannot work on the data store, local data store, when we use MONAI Label. It's a beautiful interface, and also, yeah, we have support now MONAI Label for the latest version of OHIF, which is the version 3. So I forgot to say, at the end, I'm doing a short demo. So those that are familiar with Slicer, you can download Slicer and connect the MONAI Label server that I set up. It's a small one, but you can see how it runs inference and annotate images. Most recently, so there are also private viewers that integrate MONAI Label. One of those is ScanXM. They use MONAI Label as the AI engine for training and inference. More documentation, you can go to the web page, but basically they use the server instead of the plugins. They provide a plugin, and you connect to the MONAI Label server that you can set up on your cluster. There is also a MATLAB. They integrate MONAI Label into the radiology application, so you can use MATLAB to annotate and do the active learning using MONAI Label. Recently, I think MITK also integrated MONAI Label with that. Yeah, so why you should bother using MONAI Label? So there are two personas that we had in mind when we started MONAI Label. One is the researcher. As a researcher, I want to create new methods or new segmentation methods using the latest network that is in the literature. I want to do rapid prototyping. So I want to show how a segmentation method works for downstream purposes or downstream tasks. Or I want to work on active learning strategies. So I have set up the framework to use new active learning strategies. You can do that as well. The other persona is a clinician working in a research setting. The only thing that they care is basically reducing the time annotating data sets, right? So you can, basically use the viewers that we have implemented for the different applications and start interacting with the MONAI Label server. So quickly, this is the structure that we have in, maybe this is too technical, but this is the structure that we have in applications in MONAI Label. We have the main.py file where we instantiate all the classes for inference and training. MONAI Label initially was thought as a server, but you can also use MONAI Label as a Python main script. You can run it without starting a server. And for that, you use the main.py file. We also have the live folder where you have the configs, infers, and trainers files. In the configs, you basically set up the label names and the label indexes to annotate the regions that you want to annotate on the images. You define the network architecture. You define the image resolution, and you say I want to start from scratch or train my new model or fine-tune the model that I already have in MONAI Label. We have default configurations, so you don't need to change this if you don't want. That's you want to explore and do more research on the new algorithms. And the same for inference and trainers. So in inference, you define the type of infer that you want to use. You want to use patch-based, whole volume infer, or you want to do interactive segmentation, you change there in the inference class. For trainers files, you basically define the data augmentation or the transforms that you apply to the images before doing the training. So one of the, so you say I want to play with MONAI Label, what I can do, or what is the first step? So the first thing is the type of data set that you want to use. Is it the radiology, so it's CT or MR? So you say I want to use the radiology for that. Video, you use endoscopy. I already have a model that is published in the model zoo in MONAI. So you use the bundle, right? I'm working in the, my pathologies, I use histopathological images, I use QPath, use the pathology application for that. So the first thing is to decide which application to use. Second step is to organize the data set. So this is an example for radiology. MONAI Label uses a defined, say, folder structure. And here I'm showing you a folder structure for the whole body CT segmentation model using the total segmentator dataset. So on the left, you see the structure that you have when you download the total segmentator dataset. So you see there is a folder, maybe it's not very visible, but it's a folder that contains the CT volume, and then a subfolder that contains the segmentations. In the segmentation folder, you have 100+ files, which each file basically is the region that you want to segment. In order to use that in MONAI Label, you have to organize it in this way, which is basically a MONAI Label folder. You can call it whatever you want. But then within that, you have the CT volumes and a subfolder with a labels final, where you have the same name for the segmentations with the volumes, right? So basically, you have a patient one volume, and you have patient one for annotations. And this is the way you structure the data set. So you have to define something to communicate with MONAI Label. That's the way we define it. But you can change that. It's totally customizable. You want to work with another configuration, you can do that using modifying the class that manages the data store. So this is the next step is basically say, okay, I have the total segmented data set, but I'm interested on only a portion of the segments. So what you do is go and change the configuration file. Say instead of 100+ segments, I'm interested only in 20, right? So in the configs file, you define the label names and the indexes associated, or the label values associated to those label names. So this is the second step. And again, this is if you want to train a model. I didn't specify. You want to train a model. You want to only use the models that are available on MONAI Label. You don't need to do this. This is more into changing the MONAI Label and creating a new MONAI Label app. Yeah, so that's how to create a MONAI Label app. Active learning. So what is active learning is basically a selection algorithm, right? A selection algorithm that allows the deep learning to learn fast, the deep learning model to learn fast. So there are different approaches to that. The most basic one is, so you have a model, let's say you train a model, basic one with a small number of images, and you make the model to select one of the images from the unlabeled pool, right? What is it? So you annotate the images, train a model. Once you have a model, you make the model to select one of the unlabeled images. From that selection, you update the model, estimate the uncertainty, again, or compute a number to sort or to rank the unlabeled images, annotate that or change or review that annotation, and do the cycle, right? We have that implemented in MONAI Label. You can do that by computing uncertainty from the model and from the data sets. So some of the radiology use cases that I want to show, basically use cases that we have in the Slicer hackathons. You can see here from this model was created by Dr. Rudolph. He's a thoracic surgeon. He is focused on removing lung tumors, and he uses one of the public available data sets from the medical cementation decathlon. He manually annotated, like the first version was like 10 or 20 volumes, lungs and airways, train the segmentation model in MONAI Label, do the active learning, and the model in a couple of hours, he get a reasonable model to annotate more and more images. So this is one of the use cases. The other use case that shows how you can use multi-stage segmentation models is the spine and vertebra segmentation. Scoliosis is one of the cases that we have. So in this vertebra segmentation model, we have 3 stages. The first one is segment the spine, the whole spine, crop the image around the spine. The second stage basically detects the center of each vertebra, and the final stage is fine segmentation of each vertebra, right? And for that, we use as an example the Versi dataset. We only use 60 volumes to show how you can quickly train a multi-stage segmentation model. The other one is the whole body CT segmentation. For this, we use the total segmented dataset. We reorganize the dataset in a way that MONAI Label can consume it. You can still, this is a bit old. When the total segmentator came out, we trained the model. The radiology folder is public, so you can download it if you want. And there is this command to start the whole body CT segmentation model. And yeah, for that we segment the 104 organs that are available there. This is another example. One participant in the Slicer community wanted to only focus on some abdominal organs and the lungs. So basically, they use the total segmented data set, but only for 24 organs. And again, reorganize the data set, change the config files, and train the model. Right? In fact, I think this is the default model that we have in MONAI Label. So out of the box, you install it and you can play with this model. The other one is bone segmentation. So it uses the total segmented data set, but only bones, all the vertebrae, ribs, and hips. MONAI Label also can do detection. So this is a MONAI bundle model that is available in the model zoo. So you can use the MONAI bundle app to consume this detection, land nodule detection algorithm. And again, you can use it out of the box without any changes. The same for this whole brain segmentation using T1 MR images. This model was trained on OASIS and Candy datasets. This is MONAI bundle model. This is, so there is a link to the video. This is MONAI Label being used on planning the surgery for brain removal. It was a collaboration between Neurosurgical Atlas and MONAI and NVIDIA. And for that, we use MONAI Label to not only detect or segment the tumor, but also the regions that were affected by the tumor. And this is only a portion of the project, because the idea was also to create the digital twin of the operating room and create the segmentation, the patient-specific segmentation, and then register that into an atlas, so you can plan the surgery and do less harm to the patient. Yeah, I don't know if you have questions, but I'm going to show you very quickly how MONAI Label works. I mean, not everything, but at least a piece of that. But if you have any questions or comments, yes, please.
Maybe I can direct the demo to answer some questions that I have as a new user to MONAI Label. I'm making a digital twin of vascular in upper arm from ultrasound images. So is there already a data set of ultrasound vasculature that I would build off, or like what would I have to do?
Yeah, no, that's very interesting. Yeah, no, it's very interesting. So we don't have a lot of use cases for ultrasound, but we definitely, I mean, we can talk and discuss how. I don't particularly know a data set that is publicly available, because most of the models that we have in MONAI Label were trained using publicly available data sets, right? I know use cases where they use MONAI Label on their private data sets. Some of them share the trained models, but not the data sets. I don't know of ultrasound use cases, but you have a data set we can discuss more.
Follow-up question on that. So it is possible, like, if I had scans from a clinic and I train a model, but those scans are not allowed to be shared, people can still use the model, or because, well, that's a question. That's a question more on the data set, say, owner. It depends on the hospital or the institution that you are working with. But yeah, I know a neurosurgeon. He uses CT to measure ischemia or hemorrhage, and they train a MONAI Label model and share the trained model and slice it community, but not the data set. So it is possible to do. That's my question, to share without sharing.
Yeah, it is possible. I know several use cases. Also, there is another initiative for whole head segmentation, where they basically segment the masticatory muscles, skull, brain, optic nerve, the eyes, yeah, basically all the head based on CT. So they share the model weights, but not the data set. So that's
about the multi-phase CTs in some surgical indications, contrasted as CT will be standard of care from a single patient, right? Is there a way to combine the segmentation to all the indications from multiple CT scans per case? Such that, for example, for arteries, there'll be a single scan done. For veins, there'll be a different scan done. But then you want to combine the annotation from different phases together with a single segmentation.
Yeah. We did that essentially. This project was that we used 4 MR modalities or MR sequences, and for that we had to register the modalities and then train the model with multi-modality inputs or multi-sequence inputs.
There's a way to register multiple scans.
Yes. I mean, you see a simplified version of the model here, only segmenting the regions, the anatomy, but we also segment the vasculature, the veins and arteries from the, and you can, so you don't see the veins in all sequences. You have to use CTA or specific sequence for veins and arteries. So we basically register all of them. But yeah, you can do that as well. So it's actually a very short demo. What I wanted to show you is I learned that you are already an expert in Slicer, but my idea was to show you what is the plugin in 3D Slicer for MONAI Label, the same for OHIF, and then test the segmentation model using the Radiology app, how you can correct the segmentation and then submit that to the server so you can improve the model, how to run batch inference using the web API, and maybe we have time to show how you can run MONAI Label without starting the server. But anyway, so if you, so I already download Slicer here, and if you want to play with MONAI Label, just go here and view an extension manager, install extension, you search MONAI Label here, and I already installed it, but you just install it there. And once installed, it will ask you to restart MONAI Label, sorry, Slicer, and then you will find it here in segmentation. Sorry, in active learning is the section. I can see active learning. Anyway, I moved MONAI, yeah, active here. So you have a MONAI Label here. So you click there and you move to the main plugin module in Slicer for MONAI Label. So we have space here to connect to the server, and this is the server that I made available for this demo. You can connect to that and play a small server, but you can, I mean, multiple users can connect to that and run inference. So this is the space to put the IP address or the name of the server. You can connect to that. And once it's connected, you can see here the application that I'm running. So I'm using the MONAI Label, the Radiology app, and the version that I'm using. If you are more interested in the options for training and inference, you can see training and inference options or hyperparameters to do the training, and the number of GPUs that you have available. If you're not interested in that because you want to use the default, just don't open that bit. So there is the active learning part to do the active learning strategies. You want to change that, or you want to play with a different active learning strategy. And then there is the button to fetch the next sample. And when I click next sample, it means I'm using the one active learning strategy. By default, I'm using the random one, so it's vanilla one. I'm not using a sophisticated active learning strategy. And when I click that, depending on the internet connection, you will get a sample from the dataset that you pointed MONAI Label. In this case, I'm using a public available dataset, the Spleen dataset from the medical segmentation data. In this case, I got the Spleen 16 sample, and then you can see you can use Slicer however you want to visualize the images. And then we basically place or put the segment editor from Slicer here, so you don't need to switch between modules, right? This application is set up to segment this number of photons on the volumes that I fetched. This is the automatic segmentation tab. So if I click here, because I already have a betray model, maybe it's not perfect, but at least you can use to start the annotation of other unlabeled images. So if I click here, basically I make a call to the server to run inference on that specific image. This image is in the server side, but you can also upload locally an image and run inference on the local image, right? So this already segmented the image, and you can see here in the segmented editor, I can visualize the 3D segmentation of this. Again, this very basic segmentation is not perfect. It's not high resolution, but at least you can start with that and modify the model you want. The other section is the scribbles, and this is essentially when you don't have annotated data set. So it's an additional, say, a manual tool to annotate images that we offer in MONAI Label. It's not a deep learning approach, but you can use it for annotating images. So let's say you have a volume and you want to upload a label that you already created in a different viewer. You can do that here as well. Submit it to the server. So let's assume that this was not a prediction for the model. Let's assume that I'm segmenting the organs here manually. So you can modify this. So let's say the spleen, not perfect. Look an experience and then the spleen here that let's say, yeah, this is also part of the spleen. Right? So I modify this using the manual tools in Slicer or any tool that you have in Scribbles as well. And once I do that and say, oh, I'm happy already with the segmentation that I modified, you can click here, submit label. It's basically telling the server, this now can be used to update the model. No, the server, I set up a computer to run the server. But you can set up in local as well. Yeah, so it's public available, so you can access that. You can use the APIs as well. Here, so if I go to the, let me see, I remember the name. It's MONAI Label server.dns. This is another way of interacting with the server. So you basically have all the APIs that you can consume with the viewer. So ScanXM and MATLAB basically create the viewers or plugins to interact with MONAI Label, making these calls to the server. Right? So you can make an infer request. You can get information from the model. You can train the model by making an API call, manage the data store, and do everything that you do with the user interface using the web API. The other bit that I wanted to show you is the how. So there is another. Yeah. Let me see if this works. We have another server up and running, and this is using OHIF, another viewer. And for this, I had to set up the Daikon web using Optan, where I have all my studies. And then if I open one sample here, you can connect to the MONAI Label server, run inference as well. You have the same sections. You have the options, active learning, segmentation model, Scribbles. And again, you can also run the so you can run inference using OHIF, and this is I didn't install anything. Everything works on the browser. Just one thing, because we wanted to cover many users, wanted to cover people that works on the cloud using clusters, and we wanted to cover people that want to use only the local computer, and for that we created another module in Slicer that is called Auto 3D Sec, and this doesn't need any server, and where we made available a bunch of models there using the total segmentator, but also models that people made available either using public available data sets or private data sets, but they made the model available for public use. And this is one of the models that I mentioned to you, which is, the model is public available, but the data set is not. So basically, this works. This doesn't need to set up a server. You just download the module in Slicer and play with the models that are available there. And you can also consume those models in MONAI Label. That's basically make it rounded. But yeah, that's the thing that I wanted to show you. I don't know if you have questions or comments. Yes, please.
On architecture as well, in training in the background, is it a UNAT or a different format?
Yeah, very good question. So MONAI Label is under the umbrella of MONAI. So everything that you have in MONAI or everything that you have in PyTorch, you can use it in MONAI Label. For these models, we use SecResNet mostly, but there is another model, the DPEG, that uses the UNet, UNet transformer-based UNet. But to be honest, you can use any network, so it's very easy to change it.
where is MONAI Label in the regulatory framework? People, it's so powerful that people will be using this.
Very good question. I don't know how to answer that question. I don't know. I guess MONAI Label is open source. I mean, anyone can use it and for whatever they want. So what I know is the goal of KCL or NVIDIA when they design this is create a platform, create a community, so they can basically use that to go and integrate it into their systems, right? But let the companies or the startups use this as a block and connect it to to the whole system that they offer. But yeah, I mean, it's a good question. I don't know. Yes.
Can we create a customized segmentation or can we be already existing? Like I'm used to do that in Python.
Yeah.
Like how much of training would be required?
Yeah, it's a good question. It depends on because if you're only doing research, trying to find the best network or the best combination of, say, hyperparameters, I will use MONAI and not MONAI Label. MONAI Label is when you want to use all the infrastructure. You want to set up a server and you want to consume the service from a different viewer, or you want to use the container to orchestrate another service. So one use case, for instance, is using XNAT. So we organize the data set, or they organize the data set, pull all the data set from the PAC system, put in the XNAT, and then consume MONAI Label as a service. So you train a model using the images that you created using XNAT, or you want to run inference on a pre-trained model. So you're using MONAI Label as a service. Another service is I want to create a reviewer platform where I have a pool of annotators, junior annotators or expert annotators. So I use MONAI Label as a layer, right? I'm not experimenting with that. So it depends on the use case. There are several use cases. There are people using MONAI Label to experiment, changing the network, changing the parameters, integrating their own model, doing a lot of things. But they don't use the infrastructure of the MONAI Label. It's the server side. And others are using the server side instead of playing with the network. So it depends. Yeah.
You get significant contributions from outside of the
Yes. So mostly, there are two use cases that I think is very nice worthy to mention. One is the MONAI Label Reviewer, which is basically a layer that was created by Charité University from University Hospital in Berlin. That's one of the big contributions, but mostly models or data sets. So people are I'm using using this data set, I'm using MONAI Label to train the model. So they basically make the model available to MONAI Label and people can use it. But yeah, mostly NVIDIA and KCL are the to the core of MONAI Label.
I should check.
Yeah. So there was a paper that we published with the MedSam, but we started the idea was to integrate MedSam into MONAI Label, but it was a bit difficult because the training part is not easy. So to train a SAM, you need a big infrastructure. We managed to do it only for inference, but also the performance, the SAM performance in medical images is not as great as, because it mostly work on 2D, right? But yeah, there was an initiative to that, and we published a conference paper. We didn't integrate into the core of MONAI Label, but yeah, that's. And there is also the non-UNet and Auto2DSec. Auto2DSec is basically you can use MONAI Label here with Auto2DSec. Non-UNet is great, but we are thinking of integrating that in MONAI Label as a way of servicing non-UNet models. But yeah, that's pretty much. That's what I wanted to share. Unless you have more questions.
example, on the ultrasound imaging, definitely people want to protect, you know, the kind of, privacy of the patients, and I know that's a very good challenge because there are few open data sets. I know, for example, there are some African fetal data sets, which is very small data set, and the researcher is Karim Lekabir from the University of Barcelona. So his plan is to release this kind of open data set. So yeah, so maybe that's also one way to kind of use this open, you know, data set for, you know, more kind of some training.
Definitely. This is what we did. I mean, I know MONAI Label is not very easy, it's not easy for everyone, especially when a clinician doesn't know anything about installing or creating a Python virtual environment. And that's the reason we created the MONAI Auto 3D Setting Slicer. And it's as easy as you go again to View Extension Manager, install MONAI Auto 3D Setting. Don't need to set up any MONAI Label server, just you train a model, you know, I want to use this, and there is even an example you have to, you click here and it will download that for you and demonstrate how this model works on segmenting the graphs data set for different brain tumors. Yeah, so that if there are public available data set, and most of the models that are available there, I trained it for them just to show how you can do that and how you can consume it. Yeah, good point. If I click here, I just basically start to download the patient model and run inference on that. And this is everything locally, so I'm not using any server for this. It's not a strong computer, but it will take a minute. Yeah.
Oh, while we're waiting, on the topic of privacy with data sets, I went to an interesting talk about synthetic data sets. I still don't fully understand it, but it was interesting. This guy was convinced that you can release a data set with the same quality that is not actually based on any individual's anatomy. Somehow, this feels like it would be a big part of that for the community, that we can overcome this hurdle of patient privacy, but still unlock sharing models with each other.
Yeah, no, you mentioned something, a blog post that was recently published in NVIDIA. With NVIDIA researchers created MACI, which is basically a model that allows to generate CT images. And it was published a week ago. And the quality of the yeah, so there is MACI is the name of the yes, this one. Yeah, it was published 4 days ago. So they basically synthesize CT images, and the idea is that they can use that to train segmentation models, or even to create basically create the manifold or the representation of a data set that cannot be published. But yeah, so yeah, there is that initiative. And yeah, so the presentation was complete. If I show 3D here, you will see the tumor. Yeah, you can play, you can do beautiful things here because you can also do the volume rendering and visualize the MR scan with the tumor and how they overlap. Basically, the power of Slicer combined with MONAI or MONAI. Yeah, with that, thank you again for the time.